Hello everyone, I'm academician Dr. Lilia. Welcome to Science and Me YouTube channel. The mission of my channel is to introduce you to popular science and to create a popular science encyclopedia on YouTube. We are back with an interesting popular science video. I would be very happy if you support me by subscribing to my channel and writing a comment. If you are ready, let's start the video. Black holes are fascinating celestial objects that result from the gravitational collapse of massive stars. They are characterized by an incredibly strong gravitational field that is so intense that nothing, not even light, can escape from within a certain region around them. Here's a basic explanation of how black holes work. Formation. Black holes are typically formed through the following processes. Stellar black holes. When a massive star, much more massive than our Sun, exhausts its nuclear fuel and can no longer support its own gravitational forces, it collapses under the influence of gravity. If the remaining mass after the explosion is above a critical threshold, about 2.5 to 3 solar masses, it can collapse further and form a black hole. Supermassive black holes. These are found at the centers of most galaxies, including our Milky Way. Their exact formation process is still a subject of research, but they likely started as smaller black holes that grew over time by accreting mass and merging with other black holes. Event horizon. The defining feature of a black hole is its event horizon, which is a boundary beyond which nothing can escape, not even light. Once an object crosses the event horizon, it is forever trapped within the black hole's gravitational influence. Singularity. At the center of a black hole is a point of infinite density called a singularity. The singularity is where all the mass that fell into the black hole is concentrated. The laws of physics, as we currently understand them, break down at the singularity, and our current theories cannot describe what happens there. Gravitational effects. The intense gravitational field around a black hole results in several intriguing phenomena, including time dilation and the distortion of space. Near a black hole, time passes more slowly relative to distant observers, and the space is severely curved. This effect is described by Einstein's theory of general relativity. Hawking radiation. According to theoretical physicist Stephen Hawking, black holes are not completely black. They can emit a type of radiation now known as Hawking radiation. This radiation is due to quantum effects near the event horizon and can cause black holes to slowly lose mass over time, eventually leading to their evaporation. Types of black holes. There are various types of black holes, including stellar mass black holes, formed from the remnants of massive stars. Intermediate mass black holes, with masses between stellar mass and supermassive black holes, and supermassive black holes, found at the centers of galaxies. Black holes are regions of spacetime where gravity is so strong that nothing, not even light, can escape. They are formed when massive stars collapse at the end of their lives. Black holes have two main features, the event horizon and the singularity. The event horizon is the boundary beyond which nothing can escape. The singularity is a point at the center of the black hole where gravity is infinite and the laws of physics as we know them break down. To understand how black holes work, it is helpful to think about gravity as a curvature of spacetime. Spacetime is the fabric of the universe, and it is made up of 4 dimensions, 3 spatial dimensions and 1 time dimension. Massive objects, like stars and planets, curve spacetime around them. The more massive the object, the more it curves spacetime. Black holes are so massive that they curve spacetime so much that it creates a hole in the fabric of the universe. This hole is the event horizon. Anything that crosses the event horizon is trapped inside the black hole forever. What happens to matter that falls into a black hole is unknown. Scientists believe that it is crushed to an infinitely dense point at the center of the black hole, called the singularity. However, the laws of physics as we know them break down at the singularity. So we cannot say for sure what happens there. Black holes are invisible to the naked eye, but they can be detected by their effects on their surroundings. For example, if a black hole is close enough to a star, it can pull matter from the star into itself. This matter forms a disk of material around the black hole, called an accretion disk. As the matter in the accretion disk spirals towards the black hole, it heats up and emits radiation. This radiation can be detected by telescopes, and it is how astronomers identify black holes. Black holes are one of the most mysterious objects in the universe. We still have much to learn about how they work and what happens to matter that falls into them. However, black holes are also some of the most fascinating objects in the universe, and they continue to be a subject of intense research by astronomers and physicists. Dear friend, I hope you benefited from the video. Thank you for watching today's video. If you enjoy content like this, please don't forget to subscribe to my channel and click on the notification bell to stay updated with new videos. Also, if you liked it, be sure to leave a like and share your thoughts in the comments. Looking forward to seeing you again with new videos. I can't wait to bring you more knowledge from the enchanting world of science.